Good evening, everyone. I'm Tamanna. I'm the Public Relational Head of Girlscript Chandigarh, and I welcome you all to our bootcamp about machine learning. I hope you all are fine and are doing well at your home. The mentor for our session is Mr. ANUSTUP Mukherjee, and he's a computer vision engineer. He's a former lead AI engineer at Omdena, and he worked with 3+ companies in AI development. The entire series will be for next 5 days, and it will be based on machine learning. In today's session, we will be covering the basic needs of machine learning, why we need it, how to use it, like all the basic information will be covered today. And I hope that you all make the most out of it. So, without taking much of your time, I would like to invite Sir, and he's going to start with the tutorials.
Uh,
Hello.
yeah, yeah. Hi. I am properly audible to everyone, right?
Yes, sir, you are audible.
Okay. So, hi everyone. I'm Anustup. Like she introduced, thank you so much for the warm introduction. Yes. So it's all about artificial intelligence for this session, and thank you again for Girlscript Chandigarh for having me. So everyone is freaking out. The entire industry is like freaking out. AI, and AI. Everyone is also like super excited for her this 5 days boot camp, I guess. So the term itself speaks a big definition, right? Artificial intelligence, like it's all about something supernatural, something which brings human dreams to the reality, right? So today's session is all about some basic ideology, basic approaches of artificial intelligence, or all about some amazing things about it, and as well as the basics, right? So without wasting more time, let us start today's session. So as she told about me, I am at present a computer vision engineer at Dark Horse Inc. USA, former lead engineer at Omdena. I also worked with IIT Patna as a winter AI intern, right? So what is what is AI? That the first thing comes into our mind. I mean, many of the student thinks like, okay, AI is a mimicking of human intelligence. When a machine can speak about humans, or speak like humans, or can behave like humans, that is AI maybe. So yeah, it's something about that. But to me, or to in a very basic language, or in a basic very online definition, artificial intelligence is something like, suppose you are a teacher, and you want to teach a 5 years old baby. Okay, so what do you do? First you suppose you want to teach mathematics to the 5 years old baby, right? You learn maths first, and then you approach the baby, and then you simply tell, okay, today this kind of topics I am going to cover, and the baby learns. Okay, and the baby learns. You used to teach the baby. Now, when a baby is completed, or when a baby completely learned the entire topic of the mathematics, then you are telling him to give a test. Then the baby is appearing for a test, and he or she might be performing well or bad in the particular test. This is actually what is flow of artificial intelligence. In our case, we used to have a machine whom we want to behave like us, right? So we used to collect some sort of data, and based on some data we used to do some sort of processing xyz, and based on that we used to pick up an algorithm, train the data on a machine, and we used to want the machine to behave in that pattern. So it's completely mimicking the human behavior, or completely mimicking the human architecture. Right. So this is a very one line or a single sentence definition of AI. I will be going deeper and deeper of it. Right. So before coming to any other parts, the very first thing is the parts of AI. Right. What, in which fields the AI is being distributed actually. So yeah, coming from the very famous part, that is robotics. Robotics is the hardware approach of AI. That means if you want to train robots like humans or humanoid robots, yeah, it is also comes under AI. It is a sub part of AI. Now, what actually AI is dealing on? One everyone knows, everyone used to use in their regular life. Maybe Cortana, maybe Google Voice, maybe Alexa, right? This kind of gadgets everyone used to use. So you're telling, hey Alexa, what's the weather status for today? Right? Used to tell Alexa. Alexa will be replying you, okay, today is sunny, today is cloudy, anything like that. Today's temperature is this and this and that. Right? So Alexa used to understand your language, Alexa used to read your language, and based on that, it will be giving you an output. Okay, this is all about your query. So this comes under the quote unquote part of the natural language processing. It's a single sentence language, that is when a machine can speak like a human, when a machine can understand what the human is speaking, analyze your voice or analyze your text, anything like that. This comes under, maybe it is song, maybe it is any query, anything like that, etc., etc. This entire domain comes under natural language processing. That is the speaking capability of AI. For better understanding, I used to speak AI is completely dependent on our face, on a human face, because what objects we are having in our human face is exactly the parts of AI. Now, let me explain how and why. Our ears and lips used to deal with NLP, because we have the ability to speak, and through ears we used to hear anything and we can judge it, right? So this is obviously NLP, voice based approaches or textual based approaches. Now, what about eye? The biggest part and the most developed part of the AI, computer vision. So computer vision is something like everyone uses, like your phone. You have went to market, you have borrowed a new phone, and now you are setting up your phone. So everyone used to either place a fingerprint or a facial recognition. That means one time you will be uploading a photo inside your phone. From the next time, it will be simply scanning your face, and it will be telling, okay, it is your phone or it is not your phone. So if it is your phone, you can log in inside to it, and if it is not yours, then better like next time, right? So how this happens? This is actually the term called as the facial recognition models, right? So this comes under computer vision. So computer vision is something like in a human sense, our eye helps us to see anything, to judge anything. If you are simply, if you can relate an example to biology, it's something like your eye used to take data, send the data to the brain by help of optic nerve. Brain used to process the particular data and gives you an output through the mouth, right? So this is all about computer vision. Computer vision is something like dealing with images, dealing with videos, dealing with whatever visuals we are having in our day-to-day life. So this is about computer vision. I will be giving more and more and more examples, right? So now comes to the reality portion. So how AI is creating a new reality. So I guess everyone used to use Snapchat or Instagram filters, right? So you can see like in Snapchat, several kind of faces, puppy face, pillow face, several kind of faces is being there on your image or in your live stream, right? So this is all are called you in layman's language we speak as a filter. But actually, what is it? It is an augmented reality, or sometimes it is a virtual reality. So AR VR, the most developing part of an AI. So there are, I want to give an example of biggest part of the AR VR. Like nowadays everyone is playing some AR based VR based video games. PlayStation is launching to the AR base right now, right? So it is augmented reality. That means if you want to think anything, suppose you want to convert your dream reality. Suppose you are exploring. I'm in Europe, right now, sitting in India in your dreams. So how can you be in Europe, or how can you feel like I am in Europe? It's obviously go and buy a VR class, play a VR video. Yeah, you will be feeling okay. I am there in Europe right now. So it is virtual reality. Augmented reality is sometimes when you can interact with this. Okay. So this is AR VR, another biggest part of AI. So now it's the part of predictions. So prediction is pretty most developed part, because whenever AI used to came into dominance, that means from the very starting, everyone is up to predicting. It all started from predicting tomorrow's temperature, or it all started with predicting tomorrow's weather. So everyone knows about weather prediction systems, or rainfall prediction systems, or temperature prediction systems. I had kind of things is dealing with the prediction industry. So yeah, prediction industry also helps us. Part of AIML is also helping us right now, specifically in the time of the COVID, because it's a project that we were also going to that also we are going to make it in our these 5 days. It's COVID-19 prediction system. That means today this much case is present, today this much people is being affected. What will be the tomorrow's rate, or what will be the tomorrow's death rate, or maybe how much people will be going to recover tomorrow, or after tomorrow, or what will be the amount of, what is the predicted amount of the cases in upcoming days. So this is prediction, is all about predicting future. So these are the very firm parts of AI ML. Another biggest part that is running right now is Amazon is going to launch it maybe by next year or next to next year. It is based on generative learning actually is, if you want to, I want to tell it in a special emphasis, because it's all about GANs. So it is, I used to take it on a specific emphasis, or better to tell is the giving life to any image or giving life to any video. That means everyone used to see fake image creation, fake video creation. So that kind of things are also being prevalent in the parts of AI/ML. So this is a very brief definition of artificial intelligence. So now come to again a very basic term, how AI works or how do a model works. So there are five mantra of machine learning, five mantra of machine learning, or as per I want to tell artificial intelligence. Okay, then I will be coming to machine, deep, transfer, many other things. But at first, there are five mantras of artificial intelligence. If you want to kickstart your career in AI/ML, then you have to remember these five mantras always. The five mantra is, suppose you are dealing with a problem, understand very carefully as well as listen very carefully. How you will be solving any problem by help of artificial intelligence. It's not that difficult as well. It is not that easy. It's completely logical and mathematical, right? So the very basic term is, if you are having a problem. So let us pick up the problem of COVID-19 prediction. What will be the tomorrow's or day after tomorrow's COVID-19 cases or predicted COVID-19 cases? So this is your problem. Like anyone is telling you, hey, can you predict tomorrow or day after tomorrow's cases? So the first thing that strikes in your mind, what domain my problem is lying. So what do I mean by domain? Domain is something like prediction means if I want to predict the future, it is a domain, prediction domain. Classification. Classification is another domain. That is like you are in the market and you're in the market to buy some vegetables, and you have went to the shopkeeper and you are telling the shopkeeper, okay, give me this vegetable. Let us the vegetable be X. So he used to giving you a 10 list of that particular vegetable or 10 vegetables in front of you. You have chosen, okay, this much of vegetables are rotten and this much of vegetables are fresh. So how can your brain is understanding which one is rotten and which one is fresh? So obviously there might be something happening inside your brain. So I will be coming what happens in AI/ML, not in brain, but yeah, something is happening inside your brain that is giving you a part to classify which one is good and which one is bad. So this is another domain, classification domain. Very big examples are being present over there. So now comes, okay, I have understood what is prediction, that is predicting tomorrow. Classification, okay, some sort of division. What are the other domains? So suppose when we are very young, that means we are very at our very young age, we used to learn ABCD or 1, 2, 3, 4, the number sets, right? So on that time, the teacher used to write on the blackboard 1, 2, and we have to recognize that kind of things. Okay, this is one. At a very initial, we cannot recognize it as one in our KG classes. We used to take time, 2 or 3 days to understand. Okay, this particular character is called one. Okay, this particular character is called two. So from day one I am completely a novice, and after some days, that is 2 to 3 days, suppose in day three, I can say, okay, this picture is one, this picture is one, and the teacher is writing the one every day on the same fashion on a board, or this picture is one. Okay, I understood. So that is all about recognition. I am simply recognizing the data. I am simply recognizing the character that I am seeing for last few days or last month. That's it. This comes under recognition. There is a very fine difference between recognition and detection. But this fine difference used to like create a Mahabharata in between the accuracy. That means if you can understand this fine difference, then it will be just a big thing in your accuracy. So this is recognition. For an example, suppose there is a very small number being located at a field, very small number. There is a football field, and there is a very small number present over there, right? And you need to recognize, you need to see which number it is. Suppose it is 15, and you want to see it. Then first, you have to recognize what can be the probable numbers that I am seeing. So suppose your brain is, maybe it is 14, maybe it is 15, maybe it is 16. So your brain is picking out three big probabilities, 14, 15, 16. Suppose, for an example. So this is your brain is recognizing some sort of values to the particular input or particular data. Now your brain will be My brain will be saying, okay, this number is 15 based on some particular attribute. Suppose the structure of 5 or structure of 4, anything like that. The number is no. Inside the list that is being recognized by me, inside the list, there this number is specifically and specifically 15. So that is detection. So this fine difference is being present over there. So these are the domains of AI, or domains of a model training: prediction, classification, recognition, detection, that kind of things. So another thing is present out there that is called generation. Is when an AI model is to generate. I'm not speaking about that, but if anyone is interested, they can refer the logic of GAN, generative learning. Okay, I'm not going to that part. So these are very basic domain for a beginner. So now comes, okay, recruiter told me, okay, to predict tomorrow's COVID-19 cases, the term itself speaks prediction. So my domain of problem is prediction, right? So then the next question that will come in your mind is, okay, then the problem is prediction. Then from where I can collect the data of the prediction, or from which basis I will be predicting? There might be a basis. Suppose in our 10th we used to have a problem. Ram's yesterday's salary is this. Ram's month salary is this. Ram's percentage is this. What will be the Ram's tomorrow salary? So there are three parameters based on which you will be detecting what will be the tomorrow's Ram salary, right? So there might be some data based on which I will be predicting, or there might be some parameters. So then you start hyping up on your data, right? So remember one thing: when you're starting your career in machine learning, then, or if you're going into machine learning, data is a big thing. Like data is most and most important at a very fast level, because if your data is not good, then whatever model you are using, suppose the advanced model you are using, it will be not performing well, right? It's a real time. So go for a data, pick up a good data. There are very good sites for collecting the data. You can make your own DB as well, right? So now you got a data. Okay, I have got a data. Which data I'm going to work on? I've got a data. Next thing, the next thing that should come in your mind. Okay, I have taken a data. I have understood my problem. What is the step 2? Right? We are already in standing in mantra number 1. This is all coming in the mantra number 1. Mantra number 1 again, detection of a problem, which domain my problem is lying, collecting about some sort of data, and mantra 1 is finished. So first mantra is detection of the problem, collecting data. Second mantra, the second mantra is, okay, you are done with the data, you are done with collecting the data, understanding the problem. Now you have to play with the data. Well, now question comes, why we need to play with the data? Directly I will train my model on the data? No, because the example is very easy. Because you are a stranger and another person X is a stranger. There are two strangers on a street, and suddenly they meet, stranger A and stranger B. Now stranger A, suppose you are stranger A, and stranger A meets stranger B, and stranger A got some question in the mind, right? What is the name of the stranger B? Which state the stranger B is from? What is the nationality of stranger B? Or who is stranger B? So there are some very basic questions, that comes in our mind when we meet someone. The same thing also happens in machine learning. The data is completely unknown to you actually. So you need to follow some sort of explorations. I guess many of you know data visualization, NumPy, Pandas, Matplotlib, Plotly, many packages. What they actually do on Matplotlib, why used to plot the data unnecessarily? Why? The reason being to explore what is there, what is the percentage of each and every columns, or what amount of data is present at a maximal count, what is the minimal count. Several calculations are there. So that is all about exploration, knowing a stranger or knowing an unknown, right? So this is a very important thing. So now you are done with knowing, okay, this is my stranger, I have known it, you have a complete idea about the stranger. Mantra 2 done. Now come to mantra number 3. What is mantra 3? Mantra 3, okay, you have done with the basic idea about that particular stranger or idea about the particular data. Now the question that comes, I guess everyone can relate it with the life. That is, when we know someone at depth, then we come across several problems or drawbacks of the particular person actually. Because when we know someone depth, we also know what are the drawbacks of the particular person, or what are the bad things in that particular person, right? So likewise, data is also having some sort of problems. So when we understand, okay, this is a major drawback in this particular person, we try to solve because we are a good friend of that particular person. So in the same case happens in machine learning. You need to solve the problem of the data. Now, what kind of problems data might have? Data might have some sort of missing values. Data might have some sort of problems in size. If it is an image data, then problem with the color, problem with the pixel values, problem with the size, many other things. You might plot out. Sometimes what happens, you are wanting a particular format of data, but the data you are getting, it's not the required format. Okay, you need to change accordingly. This is a lot of problems you need to solve out, you need to extract out. So you need to when you are done with solving of the problems in a data, same like we used to solve the problems of our friends, right? So you are done with that. We are already lying on mantra number 3. So inside mantra number 3 there is another twist, right? So you have solved a particular person's life, you have solved problems. Now we used to gain a curiosity. Okay, okay, now the person solved his problems, now the person is okay. So suppose I'm speaking about a friend, now it is okay. Now how the person behaves, or now what are the new mindset of my friend, or after solving the problems what is the new mindset, or if I want to go or somewhere with my friend, what will be the mindset of my friend. So you want to know the mindset again, right? So same thing also happens in machine learning. It is called as a data training. Inside the data training or feature engineering, feature extraction, anything you tell, anything, etc., right? So data training is somehow different. Different data training comes out the debugging the errors in the data, but yeah, I will be speaking this part as the feature extraction. So it means what a question comes at a very basic point, what we have studied in mantra number 1. Okay, my problem is prediction. Now my data is ready. Now based on my ready data or the data I had made, what are the parameters or what are the prime features should be present on my data that will be helping me to solve the problem. So you need to extract out that prime features or prime parameters, right? So this is all about feature training or feature engineering, feature extraction. Now we are done with that. This is mantra number 3. Now mantra number 4, the biggest part or biggest or most important part, algorithm or the training of model. So many of the students, many, 99 out of 100 students used to think like model is all about accuracy. Machine learning is all about accuracy. It's a wrong concept. Yeah, accuracy is a part, accuracy is an important concept, but yeah, the main thing is the approach of the model. I'm not telling if you need to implement a deep learning model, you need to know the backend mathematics completely. I'm not telling that. Yeah, it is very well if you know it, but at least understand the structure of approach or how the model is approaching or what is the end of the model, like what is the flexibility of a model. Likewise, if you are training with an image detection, if you are working on image detection and thinking, I will be applying linear regression, impossible. So you need to know which model fits well in which case. For that, you need to know the structure, how the model performs, right? Because whenever, suppose I am an artist. If a particular company XYZ give me a chance to perform my art, they might know, okay, this person is best in this form of. So these are the things you need to know. So based on a matching mix of your feature and a model, you pick up a best model, train the model on a particular data. Coming on the mantra number 4. This is mantra number 4, picking up an algorithm, training the entire thing, training the model based on that. Now we are again lying on the mantra number 4. You are done with model training. Now what comes as an output? So what you will do with an output? Okay, suppose I'm doing a COVID-19, you will be wait up to tomorrow, and you have seen the real time case of COVID-19 is 76 a day, and your prediction was 50 a day. Yeah, the prediction was not so good, very much less. Or sometimes the prediction is thousands a day, the case is 76 a day, suppose. So you are thinking, okay, my model is not performing well. Okay, you have validated your model on real times. Now question comes, how I will be increasing it, how I will be increasing it. Jump to mantra number 5. This mantra number 5 speaks about accuracy enhancement or model performance enhancement. How? Because whenever you are performing bad in any exam, you used to again go back to your home, and you are studying again. The same thing used to happen in machine learning. We used to point out what are the drawbacks of my model. It is called as in technical, it is called as a loss function. There are many ways to calculate the loss function, but I'm not going to the mathematical part right now. I will be going. So you have to calculate the loss, which are the points that are decreasing my model accuracy. Then you need to plot out. Suppose you are appearing for a maths exam, and the maths exam is comprising with some subjects called permutation, combination, set theory, calculus, and exam is of 50 marks, and your score is 30. Where you got a low marks, you've seen, okay, I have got a less marks on permutation combination because I'm not not so much good in that. Okay, so you have got a very less marks on permutation combination. So you have went back your home, and you point out a drawback. Now the second thing that comes in your mind, okay, then how I will be solving the problem of mine in permutation combination. Your brain used to give some ways: study in this manner, study in that manner, make a planner, blah blah blah. The same thing also happens in machine learning. By the loss function, you will be getting the loss points, or which points will be decreasing up your accuracies, right? So you're done with that. Now you need to use an optimization technique. Those who are in second year, I guess they have studied OT. It's not so much difficult like that. You will be getting optimizers in AIML as a single function or a single algorithm. But yeah, you need to use any optimizational techniques. That optimizational techniques will be coming to dominance and will be increasing up your accuracies. So that's all. Mantra hive is done. Again, go back to the market, validate your model, and your accuracy, I guess, it will be increased. So these are the 5 steps you need to always follow in AIML. Whenever any problem, any problem, that is, first is collection of a data, understanding the problem, mantra. Second mantra is extraction of some sort of features. Second mantra is exploration of the data and understanding my database. Third is extraction of the features based on which I will be training my model. Fourth is picking up a best fit algorithm, training the model, validating it. If the accuracy goes less, then jump into mantra 5. I understand what are my drawbacks and optimize the particular problem and gives an output. And these 5 steps. These are the 5 structure of AIML. Okay. So the same thing is being represented over here. So let us talk on AIML or health IT or anything like that. So before that, I will be giving some examples, but yeah, I want to show some real times, some diagrams that will be helping you to understand any problem, right? So now, yes, our problem is we have no, how we come to a basic understanding. Okay, this is AI, this is ML, this is AI, this is how we used to solve the problem in AI. This is how we work on the models. Okay, and we know how we used to deal with everything. These are the examples, some very basic examples or parts of AI. Now, many students used to ask this question, used to say, deep learning different, machine learning different, or deep machine, etc., etc. Right. So I want to speak specifically on this part first, or clear the Fahali, ML, DL, GL, anything like that, or transfer learning. Many L's are there. So it's a question of me in any student's mind, whether machine is different from deep, or whether deep learning is different from transfer learning. Then what is supervised learning? Then what is unsupervised learning? Then there are several types of learning. What are this? So I will be talking on this first. Okay. So yeah. So let us start with machine learning, or what is machine learning. It is completely right now what I have told is collecting a data, exploration it and extraction of a particular features, and then simply training the model based on a particular algorithm. And when you are done with that, okay, now validating your output or increasing that accuracy. This is machine learning. Okay, this is machine learning. This is how a machine is learning and performing according to your need. So now the question comes, what is deep learning? Then how can it be different from machine learning, or why we need deep learning? So if I want to explain deep learning, again I will be writing the same steps: data, extraction of features, exploration of the data, model training, and again accuracy and validating the output. So then, what is the difference? Remember one thing: deep learning is not different from machine learning, right? Or machine learning is not different from deep learning. Deep learning is a subset of machine learning. Is very well to say, right? So why or how they're different from each other, or why deep learning models used to give accuracy more, or why they're more computationally advanced? This type of question comes in our mind. So before to take this question, let us understand how our brain works. Everything is about our brain, because I have told artificial intelligence is dealing on only up to the human this part. Human face equal to AI ML. That's it. How? Let's say it's in the same pattern. It's an object, and it's you, and it's your eye, right? It's your eye. Uh, okay. So your eye is seeing this particular object. Your eye is seeing this particular object. Okay. So and at the back end, it's your brain. Most important part. At the back end, it's your brain. Okay. So what happens actually inside us? Object you are seeing by your eye, the data is inputting inside you by your eyes, and the data is being carried to the brain by the help of optic nerve, right? Now when the data reach the brain, suppose the data is reaching the brain, suppose the processing of an image data takes place in this part of brain, then how the data will reach from optic nerve or on the front side of a brain to that part of the brain, but the actual processing is been taking place? How? So the process is carried by some neurons. I guess everyone knows neurons are interconnected to each other. Neurons are interconnected to each other. The data is flowing in such a pattern, one neuron to another neuron, this neuron to that neuron to that neuron, then the processing part. Now the processing is done and the output is done by your face. Okay, this object is a box or a square. So how can we relate this concept in AI ML? Question comes obviously. The question is very, very simple. Again, come back to deep learning. This is all about deep learning. Deep learning is completely based on a human neural architecture. Human neural architecture. I guess many of you know neural nets, that net, CNN, RNN, DNN, LNN, many other things. Okay, so come back to the part how a deep learning performs and how it is being different from ML, right? So it is all about okay, your data is there, you have done with some sort of exploration and feature extraction. Now come to the training architecture or training part. Feature extraction you may also work, but right now I will be only speaking about the training. So yeah, there are some layers. I am simply drawing some layers. Suppose I am drawing 3 layers and then the output, right? Then the output, and I have simply drawn 3 layers: first layer, second layer, third layer. And I'm telling this layers are interconnected with each other. Okay, these layers are interconnected with each other in this manner. I'm not drawing the complete diagram. Okay, these layers are interconnected with each other. What happens? The data is flown to layer 1. The layer 1 first process the particular data, some sort of function, some sort of logics, etc., etc. It might be a logic at a timing you understand. Then it returns some sort of processed feature. Based on it, the data after processing from layer 1, it moves to layer 2. Then again processing takes place. Again it moves from layer 2 to layer 3. In this way time continues. It is called layer wise model training. That means training is happening in some layers. So obviously if it is happening with more precision, if it is happening with more time, more attention, then obviously your accuracy will be more, and obviously computational time will be more. It is the only difference from ML and DL. This is the training architecture. Only the training architecture is different from machine and deep learning. Okay. Now a question of many people comes in mind. Then because everyone is active over LinkedIn, and many people used to see in LinkedIn GAN, generative learning, because it is very new in market. It is not difficult so much, not difficult in so much extent, because it is something a byproduct of learning and maybe the future. I don't know, but yeah, it is in the market right now. Then now anyone might tell, okay, then generative learning is different from deep learning. No, this is a subset again. How? There is a very little difference in between deep and GL. How? The difference is, I have already told about the domains, spoken of the domains, that is prediction, classification, detection, recognition. I have told about another domain, generation. Okay, I have told, I will be telling it later. So now the time came to know it. Generative learning. So generative learning is completely on you. We used to paint images, we used to draw images. When we create something, that is our creation. And when artificial intelligence creates something, that is for generation. How possible? So there is a little difference in architecture of deep learning that used to create, that used to generate from, suppose your image is blurry and you want to improve the pixel of a particular image, or you want to improve the quality of the image, you may go for style generative learning. This is a model, name of a model. Suppose your model is having very low quality, or suppose you want to track in a video how the object is moving from one place to another place. You are calculating actually the pixel movement, how the pixel is moving from one frame to another frame, right? So this is, in this case, you have to use a model called as pix to pix. So this is all about, only the architecture is different. It used to generate something through a model. Only the architecture is different. Otherwise, terms are equal. So generative learning, when you used to add some special emphasis on a data, or when you used to deal specifically that kind of models, that will be, and that is up to generating something new. Maybe fake images, maybe fake video, maybe improving the quality, maybe giving a live to any particular image, live to any image, that's it. Everything comes under generative learning. Okay. So I guess everyone is clear with this three, and we will be taking the questions at the end. Okay. So keep store your questions and keep asking. And I will also sharing the GitHub links and all, etc., etc. Because we will be also creating some some works as well as the projects in this 5 days, at least a basic project in this 5 days. So okay, keep track on the GitHub. So now the question comes, another important definition, that is supervised, unsupervised, reinforcement, transfer, anything, etc., etc. So now the first thing is, you have told about machine learning, you have told about deep learning, you have told about generative learning. Then supervised learning is also any another type of learning, or it is something different like AI/ML? Okay, this is a very good question. Many of the students may ask. Okay, so it is supervised, unsupervised. I want to give an example. Give an example in such a manner. So everyone is college, or everyone is from school, maybe, etc., etc. Okay. So many of the students is present over there who are regular class bunkers. So a class bunker is a guy. Suppose there is a 30 days class, and the person comes 10 days in the class and 20 days is outside the class. Okay. So okay. So suppose the teacher, you see the boy only 10 days in his class, right? In 10 days, used to see the boy in the class, and rest 20 days used to see other boys or girls in the particular class. Right? The teacher cannot see that particular boy. So the teacher can only now, after these 30 days, in the next month, when the boy in trying to enter in the class, teacher says, "Hey, you are not in my class. You are not the student of my class, or you are not the student of this school, or not the student of this college." The student, obviously, he is to tell, like, he also cannot tell, "I am a bunker. I used to come only 10 days in your class, and just 20 days you cannot see me." The student also cannot say it, and student goes out again. So the question comes, the teacher used to see the boy 10 days in his class. So can the teacher cannot remember the boy? 10 days is enough for remembering, right? 10 days is enough. Why the teacher cannot remember it? Suppose this is the story of teacher A. Now let me tell a story of teacher B, or another very good teacher. Okay, so he can remember each and every faces of each and every students. Okay, so that the person is so much swift. The student comes after the next month or day after next month. Okay, and the teacher immediately recognize you are the bunker. You only come for the 10 days, or you doesn't come for the last 20 days. immediately recognize a particular person. Or suppose the new student is present on the class, the teacher immediately recognize, okay, this is the new student, and the person will be asking, okay, so how does this happens, or how does this takes place? So this is one thing is called supervised, another is called unsupervised. Supervised and unsupervised is better to tell an approach of a data. That means again come in the, just relate our example in the sentences of AIML or sentences of technicality. It's all about suppose you are dealing with a COVID-19 data, and COVID-19 data is something like you are predicting the COVID-19 cases for the next 6 months based on the last year data, and your data is static. You are not increasing your data or not increasing the size of the data. Suppose today's entry are not in the data, so your prediction will be very dummy prediction. It's a controlled case. But what in the real life data, the situation is not controlled. The situation is not even controlled. So the previous case or a preliminary case where a situation is controlled when we are handling with some static cases. So it is called a supervised approach, or in technical terms, it is being spoken like we used to know what about the inputs and outputs in a single sentence, but it is quite like I used to feel lame to speak it out. I am explaining everything on the points of the on the projects, or how we will be implementing the parts. So this is all about the projects, how to implement the concepts in the projects. So I'm not going into any theoretical lines. I'm only speaking about the practical lines. So the initial one is supervised learning. So now what is unsupervised in machine learning? Suppose your data is dynamic and it is increasing day by day, and a model can adopt new data. The model will be retraining each and every day based on the particular new data. It's an unsupervised approach. We know about some input parameters, but we don't know about the output. How the data will be changed, or how the model training will be changed, or how the accuracy will be changed, I don't know, because the case is not in my hand. It is something which is not controlled. Now the question comes, okay, I understood supervised, I understood unsupervised. Now many of you may come across a term, or it is a very common term right now, reinforcement learning, transfer learning. So it having the two parts. One is the super, one is the unsuper, transfer, and reinforcement. I want to speak about these four only. There are many other semi supervised, semi unsupervised, transfer, semi reinforcement, etc. But important is this four. So we know about this, we know about this. Okay, so what is about transfer learning? What is about transfer learning? Transfer learning is something all about okay, it's all about, suppose I am a teacher and I am teaching you guys AIML through YouTube live. Okay, and you guys are knowing AIML through me in YouTube live, right? So now after these 5 days, at least you will be having some sort of preliminary idea about AIML, or at least make a project of your own. Okay, so when you are done with that part, then you know these kind of things. Now there is a friend, there is your friend who also wants to know machine learning, but I cannot attend this session. He is unable to attend this session, maybe of any XYZ reason. Now you are the person who will teach your friend machine learning. How? Or how can we judge this algorithm computation? This algorithm is flowing in such a pattern. It's something like I am teaching you. That means the data is flowing from me to you, and you are teaching your friend. That means the knowledge you are gathering from me, you are simply transferring the knowledge to your friend. That's it. So it's the flow of data in such a manner, or flow of knowledge in such a manner. So this is all about transfer learning. That means suppose you want to do sentiment analysis, and you have that sentiment analysis on Amazon site, but you have a sentiment analysis data of Flipkart. So you will be training a model on the Flipkart data and using the same model for an Amazon data. A model can have a behavior in this case. So this is all about transfer learning. Learning that works on a flow, or learning that flows the knowledge from one step to another step. Right. I will be telling how to implement these logics in projects, because whenever you want to make an AIML project, you have to take care of these points. If you are taking care of these points and no algorithm, it will be done. And obviously Python. Another thing is reinforcement. Just a single line. I am not wasting more time on reinforcement, because reinforcement is something where a model can learn by itself. It is called as an auto learning process. It is still difficult for the beginner level, but yeah, It is a way out where a model can learn itself. Yeah, you have to train the model. During the training, it will be having some sort of features or attribute. You will be giving the model some sort of attributes based on which it will be have a capability to judge or have the capability to learn by its own. So this is all about reinforcement. And right now we are not considering the reinforcement mainly, but yeah, if you come across this term anytime, what is reinforcement learning, then it is, yeah, auto learning process of a particular machine learning script. Great. So now the question comes, okay, I have known about ML, DL, I have known about supervised, unsupervised, transfer, I have known about machine learning, mantra. Now the things are getting messing up my mind, right? Obviously, you will be getting messed up. So let us design an algorithm, machine learning algorithm of a particular project. Okay. Hmm. So I am not right now. I'm not taking an example of COVID-19. I will be taking an example of suppose facial recognition. So let us draw a face. Though the diagram is very bad. Okay. So this is a face of a human. Okay. Okay. So now you are on a track to create a facial recognition model. Okay. And you have did some sort of research on internet, and you have seen the approaches of facial recognition include CNN. The CNN is a deep learning approach, so by which you can do facial recognition. So your problem is recognize a human's face. It is your problem. It is a problem. Recognize human's face. Understand the algorithm flow. Understand everything in like carefully, because the flow is important for solving or making any project. So after that, you can solve any project or make any advanced things. I will be making things, but to put an introduction, so let us hamper on an introduction. Right. So yeah. So my problem is uh, like facial recognition of any face. So the first question, likewise previous time we have in your mind, which domain my problem is lying. So I am noting down the steps. First is the domain. Prediction, classification, generation, recognition, detection. Right. So the first thing that problem itself speaks facial recognition. That means it is something about recognition and detection. So the problem is recognition and detection. Now your brain strikes. Okay, I am having a data based on which I am training my model, and finally my model is detecting the face. Then what happen? Then what will happen in real time? Every time my face will not come across the camera. Maybe the face of my friend, maybe the face of my mother, maybe the face of my father may come across the camera. In that case, then the model will cannot judge. It will be only doing facial detection. So it will be telling it is a human face. Then how to only confiscate the system up to me? How to do that type of thing? Your mind speaks, okay, so it is all about judgment, and judgment is all about classification. So this problem is all about classification and detection. Why? Detection is, okay, this is a human face, and classification is whether it is your face or whether it is your friend's face. So I am writing it as D and C. You can understand accordingly. Okay, so D plus C, right? So now the next thing that comes in our mind is simply all about, okay, I have understood my problem. The next thing, what is the next step? You will be directly jumping on a machine learning mantra. Machine learning mantra step 1. Problem detection done. Now I have to understand the domain of my particular problem. Which domain my problem is lying. So you have done with that detection plus classification. Now you have to collect some sort of data. You have gone to internet and you have collected image data. Maybe the data is having 50,000 faces, 10,000, 20,000 faces, or etc. etc. XYZ. So you're done with collecting with the particular data. Maybe the data is of any format. It's up to you which format data you want to fetch, or you may also do arrangement with the particular formats, right? So you have done with downloading your data. So machine learning mantra stage 1 is done. Collecting of the data, detection plus classification or domain selection. So what's next? Obviously mantra number 2, So mantra number 2 tells me, okay, I have collected the data, but whether the model will be only speaking about this data, that means a data is consisting of face of you, your friend, his friend, and etc etc, only your known circle. So suppose a person comes in front of the camera or comes in front of your model that is unknown to you, or suppose the person is not present over the database, can your model perform? So this question comes in your mind and you are telling, okay, no, maybe because I am training the model on a single data, so can it perform? Yeah, it can perform. So if you are confiscating your model only up to your data, it is all about supervised cases. It's a controlled case. It's a very controlled case. But here we don't need a controlled case. Then the accuracy will be very bad if any unknown thing comes. How to handle this? Go for unsupervised. So here you have to select what learning you want to use. Okay, you have understood unsupervised learning. Now note it down somewhere. I want to use mantra 2 M2 unsupervised learning UL. Okay. So now again extract some sort of features, explore with your data. You are done with exploration as well as the feature extraction. Right. You have done with exploration and the feature extraction. You have done with mantra number 2 and mantra number 3, feature extraction. Now mantra number 4, algorithm selection, model training and checking the accuracy. Mantra number 4. So now again the question comes in your mind, what type of algorithm I will be using? How can I choose my algorithm? What are the attributes based on which? You have to simply search facial recognition by unsupervised learning approach. Now you can choose which sort of approach you want to use. You want to go for a machine learning approach, you want to go for a deep learning approach. ML, DL, this is all on accuracy. It will be giving you a change in accuracy or change in approaches, but yeah, I'm going for CNN approach. So you have selected your algorithm CNN and trained your model, and then again mantra number 4 and mantra number 5. So your project is done. So again, I'm just getting the things in a single line. That is, first understand problem, detection plus classification, collecting the data, then understanding the data is lying in which type of learning, supervised, unsupervised, selecting the learning, exploring the data, extracting the features, and then picking an algorithm based on a perfect learning, perfect attribute, perfect feature, perfect problem statement, picked up an algorithm, train your model, check the accuracy, and test it, increase the accuracy. So this is the how we used to work in AIML, right? So yeah, so before coming to that, I will be sharing the notebook. More than sharing the notebook, I have to speak about some libraries. Now this is all about a basic preface or basic ground phase of AIML. So let us start with the coding part because Python is the primary requirement, right? So before that, I have organized some things like in this in a GitHub. Whatever codes I will be covering, it will be shared over here in this repository. I guess link I will be shared with any one of the organizers. Okay. So just because this is the 5 days camp, and in order to make it interactive, I have organized this like this small repository, and in this repository, your entire course codes will be uploaded every day, each and every day. Yeah, and I will be giving you short projects to implement based on what you have learned today. Like you have learned today how to design your own algorithm, how to choose the domain, how to choose learning. So accordingly, a very short thing will be uploaded so that you guys can develop. So the things will be in the issues section. So I will be creating some open issues for everyone. So everyone can opt and upload their code by simply creating the pull requests. Okay, I guess everyone know how to create a pull request. So just another, I'm just telling, just come in this part. It's very easy. ANUSTUP 900 ML Bootcamp GS. You have to simply fork it, and in your fork you have to check the issue, upload a pull request, which issue you want to solve. So every day in these 5 days from today actually, several types of small projects will be there. I will be uploading, so you guys can check it up and you guys can make it so the learning will be really interactive. Okay, and otherwise everyday course codes will be present over there. This is how is actually the flow is happening, right? So better come on the next part. Yeah, so next part is the important libraries we need to know. Important libraries we need to know, and what are the uses of the library. Because yeah, the programming language that we are using is Python. Okay, so Python basics I am telling, I am going to tell it right now. Many of you may ask the question, why Python, why not R, why Python, why not Java, why Python, why not C++, Python, why not MATLAB, many, right? So the reason being, I will be telling when I will be explaining Python, the programming language is Python. And yeah, first of all, we need to know the libraries. Machine learning is all about library, framework, support packages, many, etc. things. So what is the power of the libraries, or what things we can do with the libraries? That thing we need to know. Yeah. So first come to the question, Python. Why we are using Python? The Python is such a language, and why not Java? Why not C++? So coming from a very basic flow, when a first algorithm is being designed, obviously you know DSA is based on C++. Everyone used to follow it, right? It's also on Java, but yeah, maybe 99% student used to do on C++. So you might tell, like, you are designing an algorithm, why you are not using C++, right? Why you are going for Python? So I will be not wasting more time in this language description. Just a single sense, Python supports a huge amount of the libraries, huge amount of the support frameworks. It's very much computationally advanced. It supports in biggest cloud platforms as well. So also very much easy in deployment, right? Single sentence, Python supports front end, Python supports back end. Right now, machine learning through the power of Python is supporting Node.js, etc., to TFJs, TensorFlow.js, right? So this is the power. So you can opt for Python. Yeah. If you are specifically into plotting the data, that means doing or playing with the curves of the data. That means playing with data curves or data flow, anything like that. Then you have to go for R, because data science is more good on R. Like 3D plot generation is more good on MATLAB and R. Again, MATLAB is a paid software, so you can opt for Octave, GNU Octave. These are the names of the software, right? Okay. So now another thing. So we will be using Python. Before coming to Python's syntaxes, I know 99% of the people know over here because they are following machine learning. But yeah, I will be also telling about that, and I will be also giving you the source from where you can study overnight. Okay, and come for a tomorrow's session in the live coding and start with the algorithms. Okay, so first of all, before coming to the contextual part, first come to important libraries that we need to know, because it's all about the basics of libraries. So there are many important libraries. I guess many of you know about it: pandas, numpy, matplotlib, plotly, skippy, etc. So why we need this library? Why we need this library? Because these things is needed. Why? Why need this library? Because if you are a very beginner, I have seen people making short projects, weather prediction system by using linear regression. So these things are okay, but you need to if you want to be a machine learning developer, I have seen in the companies they used to want some work in the depth, right? So yeah, so you need to know this kind of things at somehow depth. Somehow depth means how, why a library is needed. So if I can plot a data by a manual code or a manual script of code, why I need a library, or why I need to call each and everything in sort of a package? Because it will take time of installation. Why I will be doing such much of labor? So yeah, it's right. It's something like the important libraries that I have right now told about NumPy. So let us start with the very first library, NumPy. Mind my handwriting. So actually, mind my handwriting. It's getting worse day by day. Okay, yeah. So today we'll be covering the most of the theoretical parts, because I don't want to waste time on this kind of definitions from tomorrow as if. So from tomorrow as if we will start implementing the algorithms. Okay. So NumPy is the most important Python library. So why NumPy? Remember one thing, don't go in very depth. NumPy helps in the mathematical computations. Now, what do you mean by mathematical computation? I guess I am giving a very basic example. It will be also clearing some concepts from algorithms. If you're having image, right? I guess you all know image is a collection of some pixel values, because every image have some sort of pixel, right? So image is actually a collection of pixels. Several kind of pixels are, are accumulated to make an image, right? So if you're having an image, so we can represent an image numerically, obviously, because when a machine, you were reading it as an image in your visuals, but yeah, when a machine is reading that particular image, or when a machine is reading the entire thing of an image, or trying to understand an image, it is to convert it into the machine code. That means it's simply a of some a set of some numerical values. It's simply a matrix of numbers, right? It's simply full of number, full of values, anything like that. Sorry. So yeah. So suppose we want to create an image recognition system or image reduction system. First, you will be inputting an image. Then through some sort of logics or code or algorithm, your image will be converted into a numerical array or matrix, anything like that. And that will be the recognition section of your image. Your model will be understanding it through it, right? Through the particular matrix that you have created, M cross N matrix. Okay. So now the question comes: how can I handle with that kind of matrix, or how can I do? Suppose an image, whenever a matrix of an image is being extracted, now the feature extraction work will start. Now when the feature extraction work will start, it will be giving me some features, okay, but the features will also be some matrix, because from a matrix only a matrix can be generated, right? So that will be also a matrix, like f1. Suppose the feature is f1, it is a matrix m1. Suppose a feature is there f2, it is also m2. And then I have to train my model based on these features. How can I handle that much of numbers? Don't worry, there is something in Python that is called NumPy. So NumPy is there to deal with the multidimensional arrays, to deal with this kind of mathematical computations. Or now the question comes, okay, mathematical computations, okay, I have understood NumPy can deal with this now, these values, the number, right? So what do you mean by mathematical computation? So this is all comes under the logic of feature processing. Logic of feature processing, it is somehow mathematical. You have to know these kind of things because it's though very basic, but yeah, we need to know it because we need to implement this kind of logics when we will be going to learn, right? So including the future, I'm telling the things. So yeah, so feature processing. How does the feature processing takes place? There are many ways. Many ways how? Like I guess if you're in a first year, you may have studied calculating the pointing out the similar element out of an array, right? Or if you're in a second year, you know sort algorithms. So suppose you are having a set of feature. Suppose a feature is represented in this format, or a feature map, for example. A feature is some features xyz, yeah, is represented in this manner. In this manner, it is f1, it is f2, it is f3. Again, I am representing three features only: f3, f2, f1, f1, f2, f3. So these features are represented in this manner. Now suppose at the layer one, at a very layer one of the model training, or a model xyz model is telling I am doing feature processing first. How it will process? So you have to write a logic of feature processing. So now you are having a set of 10 feature. Out of that, there might be some feature which is similar. That means you are going to a shop and you are having 5 dresses, and you are seeing the 5 dresses are near about the similar, but there is difference in price. So you will be picking only the most similar dress. So you are satisfying the needs of all 5 dresses. That's it. And obviously in your price. So the same thing happens here also in feature processing. So you are getting a list of 10 features, and you are saying, okay, the processing 10 features or training the model on 10 features will take obviously a very big time. So how can I reduce my time of computation? How can I reduce it? So you have to do feature processing. What you will be doing in the feature processing? The best features extraction, or most similar feature. You will be extracting out the most similar feature. Now, just in your logic, then how can you extract out the most similar feature? In first year students logic, extracting out the similar element out of an array, and in data structure algorithm logic, those who are in the second year, they will be saying sort, extract, sorted, like implement a sort algorithm, it will be solved, right? But it is done with a very short array, but when you are dealing with the mathematical computations, it is not like that. How can we do? So yeah, it will be using some sort of logic of sort at its backend. It will be comparing one feature versus another feature, one feature versus another feature. For an example, Let's take an example, F1 versus F2 first, then F2 versus F3, then F3 versus F1 in this manner. It will be comparing and giving you an output, right? So this is all about the feature processing. So how can these things take place? How can you implement the logic of a mathematical in this kind of mathematical things? It is called as actually mathematical computation. It may inbuild the logic of mathematics multiplication. It may inbuild the logic of vectors. It may inbuild the logic of matrix subtraction, addition, etc., etc. So this all things are handled by an NumPy by the help of very short functions. Now the question comes, how can I know this, right? Because in these very short sessions, we cannot do like tell you in the line by line code, but yeah, you can learn by your own. How can you learn? How can you speak it? So simply go for numpy.org, right? Numpy.org. So it is an official documentation of NumPy. So you have to click on the documentation section, and no need to study this setup. You have to only go for this quick start tutorial and absolute beginners tutorial. Okay, only these two things you need to know: how to implement the NumPy and how to about the function of the NumPy. And now you have more time, then you can go for tutorials. But for a very basic start, go for quick start and an absolute beginners tutorial. So this is how you can start with NumPy. And if you want to brush up your concept again and again, I will prefer to go for NumPy at tutorials point. Right, I'm not typing it; it is there. Right. So NumPy at tutorials point, because we will be starting from algorithm. So in these short sessions, we cannot code up an entire thing. But yeah. Now the next thing that comes into dominance, that is pandas. Another Python library. Pandas. Okay. So pandas, how to deal with that? Or what is pandas? Before coming to pandas, let us take an example of matplotlib, because it is very important and very good as well. Matplotlib. Okay, matplotlib. So it helps in the plotting. Now the name itself speaks. It helps in plotting. So now, why plotting? Why we need plotting? I guess everyone in class 10th have drawn a bar diagram, have drawn histogram, have drawn any statistical diagrams, right? So what used to do? What used to draw over there? Some diagrams or some charts, right? That means Ram's number distribution or number distribution, population distribution. These types of thing used to do by the hand-drawn things. Okay. So if the same thing you want to do with the data, you have to take the help from a package, and the package is matplotlib. Remember one thing: the two most important packages, matplotlib as well as the plotly. And right now Jupyter Dash is being present over there. Jupyter Dash. So these three are the plotting packages. There are also packages, but these three are the most important packages. If you're a beginner, then go for matplotlib. Matplotlib is very easy, very easy. Only you have to call the things like plt.show, right? Plt.plot, plt.ggplot, plt.histogram. If you need to plot a histogram, you need to call the function in this manner, plt.histogram, in this manner. It's very easy. Python is very easy. plt.histogram, plt.show, plt.dat, this kind of thing. So again, the way of it, how we will be knowing matplotlib, you have to go for matplotlib.org. There you can get the documentation for each and every single plots I will be showing. Then you can. But the question is, because we are simply speaking from the project end approach, how can you choose your plot? So before knowing how to choose the plot, because plot also speaks, so we need to know about the several plots in matplotlib, right? So yeah, matplotlib. Official page again. Okay, so this type of plots you can go with. This type of 3D plots, distributed plots, number plots, several types of plots things present over there. Again, you have to go to the documentation part. It will be giving in the basic tutorials about each and every plots, how to deal with that. anything like that. Okay. So now the question comes, how to choose which one I need to plot. That means I need to plot my data in this manner, or I need to plot my data in this manner, or I need to plot my data in this manner or this manner, etc., etc. Which plot I have to use. So I will be explaining which plot I have to use. Right. Suppose your problem is COVID-19 prediction again in machine learning. So this very few things will be add up a very big touch up to your project, right? So COVID-19 prediction. So COVID-19 prediction before training any model, what I have told, exploration of data. How will be exploring your data? How? I have told to plot the data, right? So you need to know which state have big highest amount of the death rates. Which state? So will you be going to understand this problem with this curvy plots? No. So what kind of plot you will be going? You will be obviously plotting a basic histogram in this manner. Matplotlib that is like from Matplotlib we will be plotting a basic histogram, that is plt.histogram. Okay. So you will be plotting a histogram. Now come to another end of this project. Now you need to know the distribution. That means, okay, I am telling for a specific and specific state, that is Chandigarh. Okay, I'm telling for the Chandigarh only. In Chandigarh, I want to plot the data. That means which sectors of Chandigarh is having how much of cases, or I want to see the distribution of the containment zones. How to see this? How to see? So you will be plotting the each and every sectors in a distributed way. So it is called as a distributed plot. That means suppose it is for the sector 48. So your plot is distributed in this manner: containment zone 1, containment zone 2, containment zone 3, 3, 4, 4, 5, 5, 6. So this is called as a distributed plot. So this is again a statistical approach. Which plot will be suiting the best need of your problem, or which plot suits the best value of your problem, is again a statistical understanding, right? So now you have understood this thing. Okay, I need to understand my problem and I need to think what type of plotting I need to show, right? Now the question comes, will these plots will is going to help me further in the time of the model training? Yes, it will be. For example, there is an algorithm that is called as a k-means in machine learning. So it calculates a mean value. Okay, suppose you are having a data, I guess everyone used to know mean equal to average. So suppose you are having three data, x, y, and z, then the average of this will be x plus y plus z by 3. So there is an algorithm that deals with the very basic logic of the mean, that is called as a k-means, right? I will be telling about this algorithm tomorrow. Right? I will be implementing also a short project on k-means, SVM, etc., etc. But yeah, right now, no, there is an algorithm which implements the logic of mean values. So now the question comes, suppose my algorithm is returning a mean value of 24 based on a data. Suppose it is a set of the data present on it, x, y, z, blah, 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 blah. But I want to validate the result. There is no real-time case because it's not a real-time output that I can run the model on the market and have any sort of value or predictions. How can I validate it then? Big question. Go for a histogram. I guess everyone can remember the statistics that we have studied in class 12. Yeah, you need to clear the basic mathematics for machine learning. Okay. So the statistics I have covered in class 12, that is calculating the mean from this sort of histogram, or calculating the standard deviation, calculating the mean value, calculating mean, median, mode from several sorts of plot. So you can manually calculate the value. This is the way. This is the second way of data validation. This is the second way of feature validation. So this is the power of plotting. Plotting is not only for a visuals. Plotting is also for a mathematical logics. Okay. So if you remember these things only because I'm telling these things in details and in a different manner, just so that your project can hit in a better way. Right? Projects or whatever you are going to create in upcoming days is something solid, not like so much of easy, because just a little thing I want to share, because in my startup, because in my startup is completely a AI ML startup. So people used to apply over there in the field of AI ML developer. So generally what happens, I have seen many resumes, people are adding very short projects like weather prediction, weather prediction from a CSV value simply using a simple model and adding to the resumes and simply applying to the companies. So generally that model will also work. But when we ask the person, okay, if in this your problem, if we change this parameter to this, they used to say, no, this I cannot say, no, that we cannot say. So these things happens if you need to get a post of machine learning developer, etc., etc. Or when I was being interviewed at IIT Patna, they used to ask from this very basic points. Okay, because basics is all to rule. So this is all about matplotlib and power of matplotlib. Hope it is not so much boring, more 5 to 10 minutes, then I will be taking 5 questions. Okay, and I will be also uploading some very basic examples so that you will be getting familiar with the code in the GitHub. Over the GitHub, it will be a to Python notebook example. It will be uploading on the GitHub. You guys can access. Again, the GitHub link is ANUSTUP 900 ML Bootcamp. Okay, so yeah, now the next thing is pandas is obviously to deal with the data or to deal with the data point. So we have known about the basic libraries: NumPy, Panda, Matplotlib, Skippy. Skippy I have not told. Pandas, Matplotlib, NumPy, Plotly, Jupyter Dash. We know about this. Another library is there, Skippy. Skippy is a library. I want to tell specifically about Skippy. Why? Let's come to Skippy or Skype, pronunciation may be different. SCIPY, Skype or Skippy. Okay. So this is a specific Python library that deals with integral and differential or different types of calculus approaches. Question comes. So why we need calculus now? Right? Why we need calculus? Big question. And how can we understand or how can we implement? Right. So I guess whosoever have made at least one single project in machine learning, they know they used to plot the accuracy curves like this, or sometimes like this, or sometimes like this type of accuracy curves. How, what is the learning rate of the model is present over there. This is the learning rate of the model. Suppose it is L for learning rate and T for time. Over the time how the model is learning, it is showing that it is the learning rate is initially decreased and then increased, the inverted parabola. Okay, so first thing comes in your mind, how I will be plotting this inverted parabola. Obviously, you have to use matplotlib, but yeah, another thing, matplotlib cannot deal with the mathematical computations. Then you can go for NumPy, but the things are not so much good. So yeah, there is a Python package that deals with a calculus implementation, Skippy. So you have to, it is a collaborative effect of Skippy and matplotlib. Now, the question that comes in your mind, why calculus? Why you are speaking calculus? It might be anything else. You are simply plotting a data x versus y. No. Why? Because it is, why it is I'm saying this an approach of differential calculus, or how a calculus will be helping you in this part in machine learning, in accuracy judgments, or in artificial intelligence. It's all about, okay. So this is my learning rate. I guess everyone in class 11th have studied about maxima minima calculation. So minima speaks about what is a minimal point when it will be any condition will be like that, e2x by t2x by dy 2 greater than 0. Another condition for maxima is less than 0, right? So this is the condition of less than and greater than 0 of double differentiation, or minimal point, maximal point. That is a point where the situation will go or curve will go at a minimum, and what point it will go at a maximum. Forget everything. You see this curve. See this curve. In this curve, you can see at this very point of instance that is called T1, and at this point of instance 2. In this point, T2, L2, learning rate. At this point of instance, sorry, L2, right? So at this point of instance, the learning rate gets as minimum. That means the model accuracy is minimum at this point. So you need to plot out the drawback. At a very first time of our lecture, we have told about in a machine learning mantra, like a human understand its drawback, machine should also have to understand its drawback. How will make a machine to understand its drawback, right? It's all about life. So you need to point out the point, or a minimal point, or a minima point where learning rate gets minimum, right? So this is the point. How to find out the point? Hit 2x by d, like hit 2x by d by 2. Differentiate the particular function, and you will be getting the minimum point. You don't need to calculate. You have to only call a Python library, that is skippy.evaluate. It will be automatically evaluate your curve, and it will be giving you an answer. That's it. So for today we have learned about basics of AIML, basics of the how the difference of the models learnings are being differentiated. We know about algorithm designs, right? How to design a very basic approach or algorithm. We know the important concepts of the Python libraries: NumPy, Pandas, Matplotlib, Jupyter-Plotly, same logics, and Skippy, right? So now come to some sort of software installation or what things we are going to follow from tomorrow. I will be co-coding into the Google Colab, right? Google Colab is again a place. It is also giving an experience of Jupyter like experience. I will be using this to code the algorithms and to show you guys, right? And so you need to only have a simply Gmail account. You can search for Google Colab and you can get into this. Okay. So another thing, and if anyone want to work on its laptop or in the laptop, you need to install a software that is called as Anaconda. Anaconda. So it is the thing you need to install in your operating system. So you need to go for get started or simply go for the download action. Right, when you are done with installation of an Anaconda, it will be you have to simply go with Anaconda Navigator. Right, it will be taking a very less time to open it up. This software we are going to use from tomorrow, right? Anaconda Navigator. So yes, until and unless it gets start, again I'm writing. I will be uploading very basic example of NumPy, Pandas, etc. in a script in this particular repository, ANUSTUP 900 ML Bootcamp GS. There it will be uploaded, and also very short projects, very short implementations will be uploaded in a issue section. Implementation will have to be uploaded by you guys if you want to learn in a interactive pattern. Also, I guess my WhatsApp number etc shared. I don't know about that. I don't know about you. You can also ask on the particular implementation in live sessions. Okay. So this is all about how the codes will be uploaded. And again, if those who are very beginner and those who are very beginner in Python, and they are actually thinking, how can I code? Don't worry. Coding is simply a logic. Coding is simply a language. I will be telling them go for tutorials point. Tutorials point if you need to at least have a very basic brief idea for a night, and read the Python over the night. Read Python over the night and come for the tomorrow session. Right? Actually, it takes a very little time to open. Okay, it's being opened up. Uh, just a second. It's a little bit of slow software. Yeah. So here there are several Python approaches or several Python things that you can launch or where you can code. So specifically, you can use Python notebook that we are currently using in Google Colab. So for that, you need to only launch it up. Okay, so I'm simply launching a Jupyter notebook. Remember the steps again to start your first code, right? So this type of interface will be present over there. Then directly go to new wale section, select for your programming language Python 3, and okay, you are done. Now suppose you need to import the very basic packages. That is import pandas as pd. Import this is how we import the packages. So you might be thinking, what is PD, what is NP, what is PLT? You can change it also accordingly. It is PLT, NP. These things are simply a variable through which we used to call the particular package. That means every time we are not going to write pandas, matplotlib. So you will be simply calling the thing into an abbreviated form, that is PHP. It is a standard form, so we used to run. And if you need to run your code over here, then you have to only press Shift plus Enter, right? Shift plus Enter, it will be getting run. So I will be uploading the implementations of each and every packages again on the GitHub. So yeah, so now you can ask your questions. Open to questions. Whatever questions you will be getting to have. Whatever questions you guys are having, now you can ask.
Thank you so much, sir.
Hmm.
Guys, we are open to questions. Any questions you guys have, any queries, you can drop it in the comment box and we'll be pleased to answer them. So we have certain questions. Just a minute. Yeah, so this is our first question. Can undergraduate students get jobs in ML?
Yeah, I am right now a second year student, and I used to work in a US company as a computer vision engineer. So if I can, then you also can. That's it. ML, I used to know a guy, for a little example. I used to know a guy, Arjav Modi. He's from USA. He's not yet an engineering student. He is a class 7th or class 6 student. He already worked with a AWS team in the machine learning, NLP, virtual reality, that kind of things. Only what you need to have is the logic, or the logic building structure, or how you need to develop that. That's it. Next question, please. So obviously you can. No worry. What's the difference in between the AR and VR? Good question. So yeah, virtual reality is something like yeah. For an example, augmented reality. Augmented reality is, I guess, you use Snapchat or Instagram, right? So what happens in Snapchat? You are recording your video or simply facing in front of the screen, right? So specifically, when you are facing in front of the screen and you are choosing a filter, so now you can see when you are opening up, suppose you have chosen a doggy face filter. You are simply going like this, and also you can see a tongue of a doggy is coming up. So you are giving an argument, like you are telling a model a behavior. You are telling the machine to behave in this particular manner, right? And the machine is also behaving on the same manner. So, so this is called something called an augmented reality. Okay. Now what is virtual reality? Virtual reality, you can go to YouTube and search for VR videos, and you have to have some sort of VR glass. I used to have it. I can show it. Yeah, anything like this type of VR glass, VR box glass. Okay, so this type of VR box glass, only this type of thing you need to wear in your eyes, and you can simply you need to place your camera, and you can see, you can explore. Suppose you are playing a VR video of Europe, you can explore the Europe, you can explore the entire around, but you cannot talk with a person. You cannot you cannot interact with a person. That is called virtual reality. The next question, please. uh, mm, if I have any gap in my career, it will create any problems to get a job, sir? uh, it's a very difficult question. That means it completely depends on your resume, because sometimes it happens like we don't being a full-time employee at somewhere, but we used to keep working on short projects, like maybe freelancing, maybe contract based, or maybe without anything, our choice. So if you are having very little things on your resume, at least when you are not working, actually doesn't makes a very big difference. So I haven't seen anything like this, but this is a very difficult question. It depends actually on companies, which type of company you are approaching, which post you are approaching. Generally, for developer roles, I guess it doesn't happen. Can you explain again difference in between the different types of ML, and also give the libraries? Explain again the library. Yeah, different forms of different types of ML. Yeah, sure. Different types of ML is like, I have told about supervised learning, I have told about unsupervised learning, I have told about transfer learning, generative learning, reinforcement learning, etc., etc. Right. So yeah, supervised is again, suppose you are working on a controlled case, and my data is static and it is not going to expand. I know about the both input and output, what might be the probable output, etc., etc. So that is obviously a supervised case. Unsupervised means I don't know about the future. It's completely, maybe it's dynamic. It may change anytime. So it's completely dependent on the daily model learning, how the model is learning at every time. The output is getting different in such particular manner. So this is unsupervised learning. Transfer is again you are learning machine learning from my side, and now you are going to teach your friend. This is transfer learning, transfer of knowledge. Reinforcement, don't worry about that because it's completely auto learning of a model. For a beginner level, you don't need. Is any use of validation set than sorry, sir? Is there any other use of uh, validation set than using it for fixing parameters? Validation set, generally for the hyperparameter fixing. Being very frank, generally. But yeah, sometimes what happens, there are other things that are very deep things in validation actually. That is one thing. There is a logic that is called as a model confidence, right? Model confidence. Like model confidence means sometimes you don't track the model accuracy. You don't know about the model accuracy, but you want to know how my model is performing. You want to know. How can you know? You need to calculate the model confidence. Like you will be giving a 10 test case to the model, and out of that, you are seeing out of the 10 test cases, 9 test cases are running well. That means my model confidence is 90%. So in that manner, validation is well. Which technique does GAN use? Is it a use GAN use a basic approach of the deep learnings as well, because it also use any sort of deep learning and neural architecture that is backend. But yeah, the logics of the GAN is somehow different because it use the logics of fast AI, it use the logic of encoder models. Like these things are present over the GAN. I have best set of classification sets and some skills. Very good. Certificates are just a piece of paper. Skill matters more than certificates. Yeah, this is correct. Yeah, this is correct actually. Please, can you explain again what should be done for the unseen data in case of the facial recognition? Unseen data. Okay, the data you haven't seen. That means you have trained a model based on a particular data, and now you want any unknown person to face your model, right? So for that reason, you need to choose your approach. That means which approach you want to choose. Suppose you are working on a supervised case, then obviously it cannot detect the unknown person. Then you have to choose an algorithm that equally works well with an unsupervised case. That's it. So you have to train the entire logic. I will be teaching you guys how to write a logic on unsupervised, supervised. But yeah, a logic you have to write should be unsupervised. Please explain once again the libraries of Python. Just remember one thing: mathematical computation, dealing with the matrix arrays, etc., etc. NumPy, integral calculus, calculus approach, Skippy, plotting the data, matplotly, plotly, Jupyter dash. Difference is only the way of plot. Okay, pandas. If you need to input a data, right now this is enough. Sir, how can we get a hands-on experience in machine learning, deep learning, CV? What will you recommend? That is one to work on deep learning or CV, or how should we learn? uh, Better is working plus learning. That's it. Because how I learned is completely like because when I was coming into this part, because I was from a PCMB background, right? So when I was coming to this part, so like I was very new to that. I was very new to coding itself. So I was completely in this manner because to me machine learning was something again, bringing a supernaturality to a natural life, or bringing a dream to a natural life. That's it. So I was only thinking about the project. Okay, this might be a thing I can develop. Accordingly, I studied. That means I have read. Okay, this is my plan, and this might be the way outs of my plan. I studied an algorithm, and then I am going to implement it. So yeah, I have learned. So working, learning, these things are very good. And if you, I personally recommend is there is a planner actually. First, learn for 3 to 4 months, implement very good projects, and then start to go for any good company internships. Like don't go for any consultancies internships like that. If try to have any product based company. Uh, Working as an ML engineer is a boring and repetitive job. How do we motivate ourselves? It's not boring actually. It's completely depends on what type of work in machine learning you are doing, right? So if you are developing daily some kind of new challenges, yeah. If you feel like, yeah, I mean, machine learning several types of errors, etc., etc. is there. Yeah, so you need to improve any sort of motivation inside that. So should we do, yeah, research papers actually helps, but don't only go for the complete research papers, because initially you cannot understand it. At first you have to have the have the knowledge of each and every part of an algorithm, then go for a research paper, then it will be always help. Okay, so I guess there is no other query. Remember one thing. Remember the GitHub link. Remember the GitHub link, because codes will be uploaded over there. Codes will be uploaded on the GitHub link. I will be uploading over that. Anustu 900 is my GitHub ID. You can find it also. Referring a paper is very good. Okay. Okay. So I guess no other queries. Let's meet on tomorrow's session.
Okay, guys, thank you so much. And thank you so much, sir, for this very informative session. And I hope that you guys learned a lot today from sir. And before leaving, before ending this session, I would like to tell you all that this is a 5 day program. Today was day one. For next 4 days, we will be meeting again on YouTube live every evening at 7 p.m. So if you guys want to learn more, if you guys have any more doubts, or if you guys want to give us feedbacks, we guys are here and you can join us every day, and you can tell this, and we can discuss your doubts with sir. Thank you so much everyone. Thank you so much, sir. Bye bye.